All right. Hello, everyone. Glad to see you here. We are going to wait for a couple more minutes for all the participants to join, and we'll be starting shortly. Thank you. Okay. Good morning again. Looks like it's time to begin. Thank you for coming. Welcome to this Globe Core Tech School webinar today. And all right, we're going to talk about transformer oil regeneration today. This webinar will be structured roughly into three parts. First is what is oil regeneration, then we'll talk about why we need to do it, and then we'll talk about how we suggest we do it. We as Globe Core, and what kind of equipment we suggest for that. Before we begin, I'd like to request everyone to mute your microphones, please. We're not, as some of you have already been here know, we don't take questions during the webinar in audio through your microphone. But if you have a question, write it in the text chat. We have a dedicated team of great professional engineers standing by, and they will be answering your questions real time while I speak. Okay. So, dielectric oil regeneration. It's not a new process by any stretch. It's been around for quite a few years. This process has been in development over the years, and there are also standards developed for this process that include quality criteria. And we're going to talk about, or mention rather, we're going to mention the IEC 60422 standard. And there is the mineral oil regeneration guide and criteria for use, and that is the IEEE 57637. And that letter standard was introduced in 2015. So these standards will give us the necessary definitions and all of the parameters, and we can learn about a little more about those processes now. And the regeneration process will give us a chance to save a lot more oil and consecutively money through the regeneration process. So in addition, we're going to talk about what characteristics of oil we can or cannot improve with regeneration, because when we talk about regeneration, it's important to make a clear distinction between simple purification and actual regeneration of dielectric oil. Next slide, please. Right, so this table here, it presents the various methods for generating dielectric oil and the ability or capabilities of each of those methods. It's a very good table because if we have an oil analysis and we see that there's some problems with the oil, then looking at this table, we can immediately see what process is best for the type of contaminants that we got. So all of the processes that are associated with regeneration, they're about improving the chemical parameters of the oil. If you look at line 6, You can see them. This is a chemical process, and this process involves percolation or activation with sodium, etc. So all of those are chemical processes. Basically, when we talk about oil regeneration, it's chemical. And today we're going to talk about specific information, mainly about the percolation process and the contact process. Rather, there are other methods of regeneration, but percolation we find is the most effective one. Next slide, please. To begin with, let's talk definitions, right? So in this case, we'll take the definition right out of the C57-106-2015 standard. And it says basically that regeneration is the process of restoring the usefulness of oil by removing pollutants and decomposition products, such as polar acidic compounds or colloids. And this is done by chemical absorption from electrical insulation liquids. And this regeneration process usually involves treatment with clay or other absorbent media. So we can see that, first of all, acidic polar compounds and colloids are our main problem, main enemy. Therefore, it's very important to remove them from our oil as quickly as we possibly can, because these compounds, first, they are the result of oil decomposition and aging, and second, they actually catalyze further decomposition. So it's a vicious cycle. Once you get them in the oil, the situation goes only worse from there. Another important thing to note in this definition is that it's the chemical absorption that we use in this process, and this is the difference from the purification and filtration, and those are just purely physical, mechanical rather processes. Yeah, maybe it's time to look at the differences between them. Next slide, please. So one thing that's always important to know is which process we choose. When we talk about purification in the context of this discussion, by purification, I will mean things like filtration, things like heat and vacuum purification. So to have a baseline, we can take the C57-637 standard, and it tells us that we got two groups of oil. There is, in this table, you can see group 1, and oil in group 1 can be purified, and oils that belong to group 2, these oils are regenerated. So we must find the minimum and maximum values in the oil in order to determine which process specifically we need to use. Okay, it's very important to know what you can see that these numbers and groups are based on acidity and interfacial tension. So we need to know what these numbers mean, what they are. We're going to talk about these values a little bit and what their variations imply and how these factors affect our transformer. So it's always important to take samples of transformer oil. That allows us to find out what is happening inside the transformer. And a reasonable recommendation would be to make a complete analysis to identify the problems that exist. So when we detect some changes in the oil under normal operating conditions, so we can take appropriate corrective action, and that will extend the life of the equipment, causing the least amount of wear and tear and damage to the equipment. So understanding the changes, the reasons for these changes, and having the ability to stop the degradation process are all important to extend the service life of the transformer, and so we can take some predictive action rather than just corrective action. Okay, next slide, please. Right, let's talk about neutralization number first. We always, or often or always see this in our reports. It's called acidity, acid number, neutralization number. It's a value that we take as the acidity value. The reason it's called neutralization number is because we use this as a measure of how much base or alkali specifically we need to neutralize the oil. Now, imagine a measuring strip, like a pH measuring strip, right? Very similar to what people use in, to find out the acidity of water in the swimming pool. This strip of paper changes color if the oil is acidic, But if we add alkali into the oil to neutralize the acid, these indicator strip will return to its original color. And in the case of transformer oil, and in general, really, we use potassium hydroxide to neutralize the acid. So we measure the amount of this potassium hydroxide, KOH, that we have to use so that the indicator goes back to its neutral color. So we know it as the neutralization number. It's measured in milligrams KOH per gram of oil. So basically, how many milligrams of potassium hydroxide we need to neutralize the acid in 1 gram of oil, okay? So a large neutralization number will indicate, no, stay back. Thank you. So a large neutralization number will indicate the presence of certain polar compounds that will affect the electrical properties of the oil. And it's very important to know that these acids are polar compounds. And we know that oil is nonpolar. And this is very important for the oil to function as a dielectric, right? So if we have polar compounds in the oil, that directly affects its insulation ability, and this is definitely something we don't want. Now, next slide, please. So for those of you who've been here for the Duval Triangle webinar, this will look familiar. How does the oxidation of oil occurs? Now, it's pretty simple, okay? We have this molecular chain, a generic oil molecule. You can see the hydrogen are red spheres and carbon are gray spheres, right? So what happens is the oil is subjected to many factors inside the transformer. Some sort of energy is applied to the oil, heat most probably, right? So this energy can break the bonds between the atoms in this chain, and these atoms can separate. And what we see is that gases are formed inside the transformer, such as hydrogen, for instance, and the list goes on. So, but if we have oxygen in the mixture, which is pretty often the case in transformers, what happens is that a new series of compounds is generated. So we take oil, we add energy, and then oxygen. And so we get a new string of compounds such as peroxides, alcohols. You can have soaps or ketones, aldehydes, epoxies, and what have you. And all of these compounds they're all polar. Okay, these compounds affect the insulating ability. And another important thing is that they all contain an OH group, and that means they have oxygen in the chemical structure. Since they're polar, however, we can capture them using another polar material, and this enables us to extract these compounds, and it generally makes things easier for us when we do regeneration of oil. Okay, next slide, please. Acid. Okay, when we have problems with polar compounds like furans, phenols, ketones, aldehydes, the insulating performance of the oil goes down. In other words, we're going to assume that one of the main characteristics of the oil is affected. And the good thing, though, is that first we will see chemical changes, and only then, with a slight delay, we'll see electrical problems. So if we control and keep the condition of the oil in check, if we monitor it, we can actually avoid reaching the critical level and losing the electrical performance of the oil. And all of these compounds have a significant effect on our transformer. And here you can look at this diagram. It shows the ability of the cellulose paper, of the paper insulation of the transformer, to withstand physical stress. Okay. So the paper, when it's impregnated with good oil, low acidity, it has a much higher stress-bearing capacity than paper that is in oil with high acidity. And here in this graph, we have the number of pounds of mechanical stress that this paper can withstand. So if we look at this table and this graph, we can see that for transformers in the voltage class below 69 kilovolts, we would have an acceptable value of less than or equal to 0.2 milligrams of potassium hydroxide. Now, if we look at the graph, we can see that 0.2 milligrams of KOH per gram is actually a pretty critical value because we already lost a significant portion of the physical strength of that paper. And remember, when cellulose paper starts breaking down, that's really bad news. That's, the transformer lives only as long as it's solid insulation. So it's very important to keep that paper intact. So if we work with transformers with voltages above 230 kilovolts, 230 kilovolts, then situation is different because the limit values for this voltage class are lower. And since the paper begins to deteriorate and break down strongly under the influence of polar compounds, and we see great degradation already at the beginning. So even in the initial stages of the formation of these compounds. For this reason, the laboratories revolve around 0.5 milligrams of potassium hydroxide, which is thought pretty safe for transformers, but 0.5 is quite high. So if I really want it to be safe, I'd recommend to use a slightly more demanding value just to be on the safe side and to maintain the useful life of the transformer and extend its service life as much as we can. Next slide, please. Okay, so we've already seen that when we have application of energy and we have oxygen, and we'll be able to see new compounds forming in the oil, and those compounds will reduce the life of the transformer. And there are certain natural processes that also take place in the transformer that can damage transformer oil even at a greater rate. So this table shows the information about an experiment that was performed at Doble Laboratories in the United States. And what they did is they determined the effects of other substances in the oil that could act as catalyst to this process. And in this experiment, they used iron, they used copper and water. And all of these three can be easily found in just about any transformer, right? So first, they did a control test just to establish a baseline. And what they did is they heated the oil to 150 degrees, but they did not add any contaminants or catalysts, so just pure oil. So we see that there were no moisture catalysts. Moisture content was low, let's say less than 10 ppm. And under these conditions, they heated the oil for 3,500 hours, and the neutralization number reached 0.17 milligram of KOH per gram. So, and 0.17 is still within the limits for transformers with voltage class below 69 kilovolts, right? But for transformers above 69 kilovolts, this is already unacceptable. So now after this test, we already have a specific value that serves as our baseline. And from there, they added moisture without any catalysts yet, just water. And the amount of water was 50 ppm. So just to remember, the standard allows up to 35 ppm. Okay, so they began an accelerated decomposition process, increasing the temperature of that sample. So after more than 3,500 hours, they had a value of, let me see what it was, 0.9. It was 0.9 milligrams of potassium hydroxide. So that's already a pretty significant number that is way above the requirements, even for the transformers below the 69 kilovolt range. So then they added iron as a catalyst with a low concentration of water. And after the same 3,500 hours, the neutralization number went all the way up to 0.65, again, outside of specs. So when we start to see, what we start to see is really surprising when we use combinations of catalysts and moisture. So in the next test, it was iron and moisture, and it only took 400 hours of this test for the neutralization number to jump all the way up to 8.1 milligrams of potassium hydroxide. You can understand that 8.1 is a lot, considering that 0.2 is actually our maximum for 69 kilovolt range transformers. They repeated the process then, but with copper, only using only copper and a low amount of moisture. And after 3,000 hours, the neutralization number was 0.89, also too high. And then they performed the most stressing test of them all. They took copper and moisture, and after only 100 hours, they discontinued the test because they saw sludge formation, and the neutralization number was 11.2 milligrams of KOH per gram. It's extremely high. It's over 10 times that of what we, over 5 times what we had, the maximum that we have for 69 kilovolt transformer range. All right. So what does this tell us? This tells us that inside the transformers, there are things that we can control to a degree, okay? This will allow us to extend life of the transformer if we stay on top of that. So, for example, we can control the moisture content in the transformer. There are methods to dry the oil. We can also, to a certain degree, control the what kind of metals we have in the transformer. So we want to keep track of that to prevent these metals from acting as catalysts in the decomposition process of the oil. Next slide, please. Now that we've talked about acidity, let's talk about interfacial tensions for a bit. So interfacial tension, what's that? We have two phases, okay? Two chemicals, two substances that don't mix, okay? So don't dissolve in each other. And we have a border, a boundary, or an interface. This interface between the two compounds there are many things to refer to: interfacial border, interfacial layer, interface, boundary. There are many ways of talking about it. So the boundary between two liquids in the leftmost picture, you can see. Also, it can be between a gas and a liquid and a solid and gas, or solid and solid. It's all the same thing. So what's important about interfacial tension is that polar compounds in the oil dramatically reduce the interfacial tension. So the interfacial tension is actually more sensitive in at the start of the decomposition process, but also it's influenced by the general quality characteristics of the oil, and the effects may be more or less pronounced depending on the oil. And it's very important to analyze and know the interfacial tension and acidity, and to measure these things, just to know the condition of the oil and the transformer. Because when we see these things start to go out of limits, that's a good sign of premature aging of the oil, and therefore the aging of the transformer. Now, when we find this, when we see that, the first thing we have to do is to get rid of the material or substance or problem that causes this premature aging, and then we can regenerate the oil. Okay, next slide, please. Right. So interfacial tension, it's measured in millinewtons per meter, and it's a measurement of how much force we have to apply to move an object, or transition an object from one phase to the other phase. And polar compounds, as I mentioned, directly affect this value. Acceptable values are above 32 millinewtons per meter. Anything from 32 to 28 millinewtons per meter is questionable, somewhat problematic, and anything below 28 millinewtons per meter is unacceptable. Okay, next slide, please. Right, so another problem is that polar compounds increase the affinity of oil for water. Okay, again, oil is a non-polar compound, and water is a polar compound, and this polar compound degrades the electrical insulating performance of the oil, and it's very important to keep these values under control and in check in our systems. Next slide. So regeneration of oil is basically removing the polar compounds. In the process, we also remove some moisture and some other contaminants. Another important point to consider is that the regeneration process also removes something that we call oxidation inhibitor. Okay, so by regenerating used oil, we return the oil to its original performance characteristics and its original chemical composition. So what we do is a reset of the oil, like a hard reset, and we bring its parameters back to the original. One important thing is that if we do the regeneration of oil inside the transformer, we also wash away the contaminants that are absorbed by the cellulose, by the solid insulation. And as the oil circulates through the transformer in the process of regeneration, basically we take old oil, we regenerate it. It goes back into the transformer. It mixes with that old oil, so it gradually becomes clearer and it gradually becomes more pure, okay, less acidic. And this oil starts to dissolve the contaminants, the sludge that is in the solid insulation. And as it circulates through the regeneration plant, these contaminants are removed. That's the good thing. However, there's also the bad thing, okay? Because if the oil has an oxidation inhibitor mixed in it, that oxidation inhibitor is also removed. So whenever we regenerate oil and whenever we want to maintain the oil, to keep the oil inhibited, then we must add this inhibitor back at the end of the process, okay? Next slide, please. So, okay, inhibitors. These are compounds that are deliberately added to certain oils to improve their oxidation resistance. And there are several types of dielectric oil, actually two types, right? So we have type 1 oil and type 2 oil. Type 2 is oil that has inhibition compounds. These compounds react with oxygen and various other elements which cause decomposition of the oil. And when the inhibitor reacts with these things instead of oil, the results or the products of these reactions are not harmful to the dielectric oil or its performance, okay? And this slide has some really difficult to pronounce names of the oxidation inhibitors, but DBPC and DBP are the two inhibitors that are commonly used, okay? Right, next slide, please. Okay, so the permissible content of inhibitor in the transformer should be somewhere in the range of 0.2 to 0.3% by weight of the liquid. Now, it's important to remember when we talk about this that we talk about weight, okay? We use weight, not volume, when we calculate the inhibitor amount. So we do it in kilograms or pounds, whatever the case may be, not liters or gallons. And this is important because if we mess up our calculations and add more oxidation inhibitor than we need, this will actually harm the oil. It will not help it. It will break the oil. So it's important to maintain the inhibitor levels. Anything less than 0.1% is basically the same as uninhibited oil. Values between 0.2 and 0.1 are uncertain. Anything greater than 0.2 and less than 0.3 is the optimal amount for dielectric oil. So when the inhibitor is depleted, it becomes depleted with time. I said it reacts with oxygen, for instance, and it gets depleted. So it's important to add it back again if you want to keep the oil within the performance parameters of inhibited oil. So once again, please remember to calculate the amount of inhibitor needed based on the weight of the oil. Just a side note, density of the oil is about 0.87. So 100 liters of oil would weigh approximately 87 kilograms. Next slide, please. Okay, this is a fun little graph. It shows us an example of the effects and benefits of the oxidation inhibitor in the insulating fluid. And here we can see a blue line. This blue line represents the amount of oxidation inhibitor, and the red line shows our interfacial tension. The green line here is the acidity or neutralization number of the dielectric oil. And you can see that on this graph, it also shows the color of the oil as a function of, I guess, type. Okay. So as long as we have a certain amount of oxidation inhibitor in the system, some sufficient amount, the interfacial tension and the neutralization number are all within acceptable limits. And we can see that as it expires, as it's depleted, the changes in acidity and interfacial tensions don't just occur immediately, okay? So there is a slight color change in the oil, but acidity and interfacial tension are all good for now. So, and this gives us the false safety impression. We might think that there is actually no problem in the transformer, but what happens in the transformer is the transformer functions as a filter, as an absorbent itself, because it absorbs the pollutants and the contaminants, Gradually, the oil becomes darker slowly. And then something important happens, and you will see this in this graph when things start going bad rapidly, okay? And this means that the transformer can no longer absorb these contaminants. It's reached its saturation limit. And so these products remain in the oil. And suddenly we have a serious loss in performance characteristics and in the deterioration of the chemical properties of the oil. And as we can see from this graph, the problem did not occur when the color changed or when acidity increased or when interfacial tension dropped. The problem starts when the oxidation inhibitor is depleted. So if we stay on top of that, if we keep track of the oxidation inhibitor content, we can identify any problems early, and we can actually prevent this problem from ever happening, okay? Next slide, please. All right, so what happens when we regenerate transformer oil? We affect the oil, excuse me, in three large areas, I suppose. We're going to affect the physical properties of the oil, such as viscosity, interfacial tension, visual appearance of the oil. We will also influence its electrical performance, or dielectric rather, such as power factor, breakdown voltage. And finally, we are going to influence the chemical properties of the oil, such as the neutralization number and inhibitor content. Okay. Next slide, please. So the regeneration process that we suggest uses Fuller's Earth. There are other processes, they're less common. The standards don't speak much about those, but the IEC 6422 standard defines Fuller's Earth as an active material that contains active polar nodes, both inside and outside. And this property of Fuller's Earth allows us to capture polar compounds, but we let the non-polar material, the oil, basically to pass through unhindered. Okay? And this is the essence of the process. Oil goes through, and the polar contaminants in the oil are captured by Fuller's Earth. What is it? Okay, Fuller's Earth, it's a material that is obtained as a result of processing certain minerals. It's originally mined in Brazil. It can also be found in Georgia, in the Crimea, and it can also be found in various places in Europe. It has long been used to bleach wool and fabrics, and therefore it acquired the name bleaching clay. Initially, farmers used it to remove grease stains from wool, and so it is also known as bleaching clay for that specific reason. Now, there are two types of clays, and we can go to next slide, please. There is LVM and RVM clays, and the difference between them is that one operates at higher temperatures best, and the other operates best at lower temperatures. So these types of clay are different, and we can use each of them for a specific purpose. For example, LVM has a high absorption capacity for acid, and it absorbs water really well, but it does not do much about color, okay? So it's not effective in everything. We can achieve good oil parameters, but the color will still be slightly dark. On the other hand, the RVM clay improves the color of the oil, but it has a lower water absorption capacity compared to LVM. So, and the ability to absorb acids is just about the same as that of LVM clay. And just a quick side note here. Using Fuller's Earth to remove water is not something I'd recommend, because there are more economical and simpler processes for that. We can use thermal vacuum processes, for example. And thermal vacuum process, it does not involve any consumables, right? It's just a vacuum chamber, basically a filter. But Fuller's Earth, there comes a moment when it's saturated and it needs to be disposed of in some manner, okay? And Fuller's Earth, when it's saturated with these contaminants, it's a hazardous waste, so its disposal can be quite expensive. But good news, and I'll come back to that in just a few minutes, that Fuller's Earth can be reactivated and reused up to 300 times, depending on certain specific process parameters. Okay, next slide, please. So in terms of transformer maintenance, we got two types of Fuller's earth. There is AARVM. This is a Fuller's earth with the maximum bleaching ability, and it's recommended for use in moisture-free systems. And there is also AALVM clay, and that removes acids in humid oil really well. So below you can see a microscopic picture of Fuller's earth, the pores inside the Fuller's earth, and these pores is where the contaminants are trapped that we remove from the oil as it passes through the Fuller's earth. Okay, next slide, please. All right, so, okay, if we touch on the topic of material in the regeneration process, the first thing we get asked a lot is how much oil can be processed with a certain amount of Fuller's earth. Okay. This is a variable value, and the C57637 standard includes a table where you can see how much Fuller's earth is necessary to process a gallon of oil. A gallon is 3.7 liters of oil, actually. So this table shows the initial neutralization number. That is the, actually, next slide, please. Next. Okay, so this table here shows the initial neutralization number, and at the time of sampling. In our chart, on the chart here, we can see marks from 0 to 2, and 2 milligrams of kVh per gram would be a very high value. An acceptable value is 0.2, as I mentioned. So with an increase in the initial neutralization number, the required amount of Fuller's earth increases proportionately, and the curves here in this graph show the final desired values in the regenerated oil. So let's take a value. Let's make a projection from our initial value to our desired value. We'll plot it on the y-axis, okay? And this will allow us to determine the amount of Fuller's earth in pounds that is needed to regenerate 1 gallon of oil. Okay, so the absorbent capacity of Fuller's earth is influenced by many parameters, such as temperature, there's a flow rate, wheel viscosity, and its initial acid number. The European standards specify the temperature at 60 degrees. There are commercial processes, like ours, for instance, that don't use heating. There are processes that do, and it's a bit of a controversial topic because if we use heating incorrectly, some sources claim that in a Fuller's earth process with incorrect heating, we might run into problems with corrosive sulfur. So in globe core equipment, we don't use heating in the regeneration process. Okay, so let's take a certain value. Okay, let's assume the initial neutralization number is 0.8, and we want to achieve 0.05. Okay, so look at the number, the 0.8 here, and we can move our line to our desired value, plot it to the final number. Say we want to achieve 0.05, okay? So when we translate this value from the y-axis, it turns out that we'll need approximately 1.7 pounds of Fuller's earth for every gallon of oil that we regenerate, okay? So let's now consider the total regenerative capacity of one of our regular plants. One of the best-selling regeneration plants that we got, specifically our 2-column model, where each column contains 130 kilograms of Fuller's earth. So this allows us to regenerate 1,276 liters of oil. And 1,200 liters of oil is a relatively small amount. It's something which you might expect to have in a 1 MVA transformer. So we use 260 kilograms of Fuller's earth in this machine, and that's 573 pounds or so. So a significant amount of Fuller's earth is actually required to regenerate a relatively small amount of oil, okay? So apparently, but what we do is we got a process that allows us to reactivate the same Fuller's earth. And if the conditions are right, and they're mostly right, okay, it can be reactivated as many as 300 times without replacing it or disposing of it. And let's redo our math. In this case, it turns out that the same amount of Fuller's earth, and that's 260 kilograms of earth, can suddenly regenerate 300 times more oil. And that comes up to 382,000 liters. So going from 1,200 liters to almost 400,000 liters is pretty serious, because we do this with the same 260 kilograms of full reserve. Okay, so you can see how efficient this technology can be with the reactivation of full reserve. Okay, next slide, please. Okay, so we've talked about regeneration. Now, what if we just replace the oil, you might ask? Okay. Sure, we can change the oil if a company doesn't have any dedicated regeneration equipment or doesn't have access to the service of oil regeneration. But the problem is that it's just a palliative process. Okay, the results are limited. Remember, I mentioned just a little before that there is contaminants trapped in the transformer, and as soon as we replace the oil, okay, we change the oil, these same contaminants that are trapped in the transformer, they're not removed from the transformer with the oil, not all of them, okay? So there is acidic oil remaining in the paper and in the windings, okay? So that's not removed. As soon as we add new oil into the transformer, these same acids begin to act as a catalyst, and they start breaking down our new fresh oil in the transformer, okay? This is one thing. Also, of course, there is the downtime, because we need to shut off the transformer when we do this replacement. We need to stop the transformer, then we fill the oil, and then we need to wait for the oil to permeate the paper. And we need to, for the level of oil in the transformer to stabilize, and for the oil to stabilize in the transformer. All of this takes time, okay? And besides, there is also the cost of the new oil that we have to buy, and the cost of disposing of the old oil. And you know, the transformers can contain a lot of oil, so this would be pretty significant. Now, I mentioned that the contaminants from the transformer will contaminate the new oil. And yeah, basically in under 1 year, you will have the same quality problems with the new oil, okay? So what happens is that this process of changing oil is just basically generates oil waste, and it wastes time. And it's a process that does not achieve any long-term results, really. So if you compare the costs, all factored in, all the costs of oil change and the cost of oil regeneration actually becomes cheaper than oil change and oil disposal, okay? Next slide, please. Next slide. Right. There is also the environmental impact. Okay, oil is a contaminant, so it's the environmental footprint is becoming more and more important for businesses, which is a good thing. So companies begin to approach the problem of oil replacement or regeneration professionally. And mineral-based electric oils used in transformer is a very hazardous pollutant for the environment, and it's a health hazard. It remains so throughout its entire life cycle. The worst effect is probably on the aquatic marine ecosystems and the human health. Okay, so oil, if we spill the oil, there is a lot that can go wrong. We can contaminate the soil, we can contaminate water, groundwater, and that's something we really want to avoid. Okay, oil is a very strong pollutant. It's about 5,000 times more harmful than wastewater from sewage systems, and 1 liter of oil, just 1 liter of oil, contaminates 40,000 liters of water, which is the equivalent of an annual per capita household consumption. So you can see how this is important, right? Next slide, please. Next, thank you. So the regeneration process reduces this environmental footprint, and it also gives us excellent benefits and long-term results for our oil-filled equipment. Regeneration eliminates the need to consume thousands of liters of new oil to replace oil, and it also reduces the time costs. You know, that we don't need to stop the transformer anymore, because the regeneration process can run with the transformer online and energized. Okay, this requires certain safety precautions, but it's still perfectly doable. Another important thing is there is no need for a long wait for the paper to be permeated with oil. We don't need to reduce the oil level of the transformer. Okay. Another point in favor of the regeneration process is the effect it has on the contaminants in the transformer windings, and I've mentioned this before. So during the treatment of oil, the regeneration of oil, the oil circulates inside the transformer, and it washes out the contaminants from the windings. And as it passes through Fuller's earth, these contaminants are captured, and oil goes back into the transformer, cleaner oil goes back into the transformer, and it extracts more contaminants from the windings. And you know how you can see how this cycle goes. So basically, we can also reduce the effect of acids on the cellulose paper, cellulose insulation. Okay. So when we do this online, when we do the regeneration process with the transformer energized, there is no transformer downtime. It continues to run and operate. It's also a good advantage of the process. Okay. Now let's see some practical applications of this technology. Okay. Next slide, please. Okay, this was done in Chile. This is the CMM6RL unit in Chile. On the right, you can see the photo of the plant. And on the left, you will see samples of transformer oil taken before and after regeneration. I'm pretty sure you can guess which one is which. Okay, on the left, in the left container, you see the oil before the regeneration. On the right, the clear oil is after regeneration. Even from appearance, you can see that the changes are quite significant. Okay, next slide, please. And here we have a little video. Okay, so this is a project that was done in Guatemala. If you look at the two hoses in the video, you will see the darker one goes into the regeneration plant. Regen plant. This was a 6-column machine with 6 columns of Fuller's earth. So the darker hose. Also, this plant includes vacuum degasser for purification. So these columns are the columns that contain Fuller's earth, and towards the end of this presentation, we'll talk more about this. You can see here, here's the control panel, or just a little bit of it, but it's a touch screen panel for control. The processes are largely automated. Okay. And here you can see this is the contaminated oil hose, the brown one. And this clear hose is the oil that comes from the regeneration machine. And it goes right back into the transformer. So we cycle the oil from the transformer into the regen plant, and then out of the regen plant back to the top and back into the transformer again, like that. Okay, next slide, please. Okay, this is a project in Greece. In 2020, in Greece, there was old electrical insulating oil drained from a high voltage switchgear and from a 40-year-old transformer. You can imagine how contaminated that was. So the CMM12R unit performed automatic oil regeneration. Performed an automatic oil regeneration without operator intervention, restoring the oil completely to as good as new condition. And there was about 7 tons of oil in that project. The process was done in 2 passes through the regen columns. And between the passes, the sorbent in the column was reactivated. And I promise I'll tell you how this works in a minute. So the reactivation process between the cycles took 15 hours, was automatically done by the unit's PLC. So and you can see here in this video, the 2 side glasses. This is the flow rate through the plant. This is the incoming oil. You can see how dark that is. And this is the regenerated oil, much lighter. And you're not limited to 1 cycle. You can, if you're not happy with okay, this is the vacuum plant, the vacuum degasser and dryer for the oil. This is the control panel. Again, you can see how easy it can be to control this machine with just a touch screen. The process is automatic. Okay. Again, flow rate, incoming oil on the right, regenerated oil on the left. Let's see. And the degasser. Okay. So it's a combined, comprehensive solution for the oil, both for regeneration and purification, and one and the same in one machine, pretty much. So I'd like to emphasize just in the CMM12R that was used in this project. Okay, yeah, this is something impressive. Okay, the stages of the oil regeneration from dark to light. Okay, we get some of the control panel. So anyway, what I was going to say is that the CMM12R machine and generally all of the regen machines that we got, they feature very precise, very smooth controls for the process, a very accurate management of the process parameters, of moisture control, of moisture content control, and it actually measures oil color to give you an indication of how efficient the process is. It uses soft heating for degassing. Again, there is degassing after regeneration, and the machine can work with energized transformers that don't need to be taken offline for the process. And there is also the ability to monitor the process remotely. Okay, this is a feature available on this specific CMM12R unit. And in this case, the operator managed the reactivation process completely remotely. And after reactivation, the sorbent was again used for regeneration of oil. And this is a cycle that can be repeated over 300 times before we actually have to replace the Fuller's earth. And okay, just one thing, when we replace Fuller's earth, we run one last reactivation, burn out all of the contaminants from that Fuller's earth, and then it turns into a very inert powder that is not toxic, not hazardous, not anything. So it's just, you can treat it as sand pretty much. Okay, next slide, please now. So let's talk about the regen plants, and we'll use the CMM6RL regeneration unit as an example. Of course, the most important components here are the Fuller's earth columns. And what they do is they contain the absorbent material, which removes the contaminants from the dielectric oil that passes through it. These columns have heaters at the top, and these heaters are used to increase the temperature and ignite that sorbent for reactivation, because that's what the reactivation process is. It's burning. Okay. So these heaters are switched on for a short time. The contaminants in the Fuller's earth start burning, and the burning goes from top to bottom of the columns. And of course, there are temperature sensors. You can see here T1, T3, and T4. Those are temperature sensors. And yeah, they allow us to monitor the temperatures of Fuller's earth during their reactivation. So each of the columns contains approximately 130 kilograms of Fuller's earth. And if you remember the math we did a little earlier, you'll understand that that would be sufficient to regenerate quite a significant amount of oil. Next slide, please. Okay, these are buffer tanks. Okay, the buffer tanks are designed to contain oil, both for processes in which oil level may drop as a result of the regen process, and for the reactivation of the Fuller's earth. So there are actually two tanks inside one. You can see one external tank and one inside it, and that additional tank collects pollutants and water during the Fuller's earth reactivation process, basically condensate. So when the full earth reactivation process is over, the oil from the buffer tank returns back to the columns to prevent oil level from dropping in the transformer. Okay, so these tanks have a measuring indicator, a level that allows you to estimate the amount of oil in them. There is also a high level sensor that signals that the upper level in the tank is reached, so something should be done about it. Okay, next slide, please. There is the suction system, the vacuum system. that system circulates air through the columns with Fuller's Earth. It serves two purposes. Okay, first is to to supply air and to increase the temperature during reactivation. Okay, so with the heaters heating the sorbent and with air and oxygen coming in, this is when the burning starts and when we burn out all of the captured contaminants from the Fuller's Earth. Okay? And the second purpose is after the completion of the burning process, we pump air through the system to cool it down, basically, before we can start pumping oil into the columns. Obviously, it has to be below a certain temperature, for safety. So this air also cools down the sorbent. This suction system is equipped with a carbon filter, and that carbon filter, it's a charcoal filter rather. It prevents any of the contaminants from escaping with exhaust from the reactivation process. So we scrub the exhaust gases to make the process as friendly as possible to the environment. Okay, next slide, please. This is the a general view of the machine, rather a process diagram, really. So oil passes through the columns. The columns capture the decomposition products. So as soon as we need to reactivate the Fuller's Earth, and you will see that the color of the incoming and outgoing oil becomes similar. That means that the Fuller's Earth is saturated. So now we need to start reactivation. Okay. So we drain the oil from the columns and we ignite the contaminants in the columns. And the process is like a cigar. There is a burning layer that moves down from top to bottom and burns out everything that the Fuller's Earth accumulated. And as soon as this high temperature process is over and the temperature in the columns decrease, we use the oil from the buffer tank. We supply it back into the columns, and then the regeneration process is resumed. Okay, and in the next slides you will see this in animation. Next slide, please. So you can see how oil is pumped and distributed to each of the columns. So when oil goes into the columns and after the regeneration, it goes back to the transformer, or if we can also do this and regenerate oil in a tank, not necessarily a transformer, but anyway. The amount of oil that we can regenerate in one go depends on the quality of the incoming oil. Of course, if it has a lot of acid, a lot of sludge in it, then of course, it'll take, it will take more time. Okay. It's also important to control the circulation rate, flow rate of oil, because it's one of the main variables in the regeneration process. The retention time, how much time the oil spends in the columns, how fast it goes through the columns. So if the oil is in really bad shape and we need to improve the efficiency of the process, then we need to slow down the flow rate for better quality. Okay. So as soon as Fuller's Earth is saturated, then we need to reactivate Fuller's Earth. And this we can see on the next slide, please. Right, so this is the reactivation process, and it begins by supplying air through the columns and sucking all the remaining oil into the buffer tanks. And then after the oil is pumped out of the columns, then the sorbent material is ignited by the heaters installed in each of the columns at the top. Okay, and the temperatures in this process, they go all the way up to 750 degrees centigrade. So it's quite a hot process. And the burning removes the captured degradation and decay products of the oil. Okay, and when the temperature in the columns rises, the remaining oil, the condensate, goes into dirty oil container in the buffer tank, and the absorbent is then blown through with a stream of air. Okay, so when this process of burning is over, we cool down the absorbent media by purging it with air again, and then the unit is ready for a next cycle of regeneration. And this can be repeated 300 times. We say it can be 200 maybe times, but it really depends on the quality of oil. If the oil is decent, well, it's oxidized and it has acids in it, but there are certain limits. Okay, so the number of reactivation cycles possible can vary with the quality of oil. Okay, so and this can be repeated for 300 times, what have you. Okay, so yes, this is about it. That's the whole process. And we've talked about the most important points of regeneration, but it's just a brief presentation. There is a lot more to the process, and I'm sure you've had a lot of questions during this presentation. And you can send any of the questions you may have to our email. We don't answer any questions. We don't leave any questions unanswered. So we'll get back to you with answers. If you need a certificate of being here, of participating, please let us know in the mail or by typing this into this presentation chat in Zoom. Okay, so I'm glad to have had this chance to speak with you today and to tell you about the regeneration process and our tech. It was an honor. So we're going to have more webinars on more exciting topics later on. So stay tuned, check our website, make sure you don't miss anything. And I'm looking forward to seeing you all back again here at some future point. Again, appreciate your attention. Thank you and see you in the future. Goodbye.